plays an essential role in a nation's economic infrastructure systems. Let's take the UK as an example. There are over 70% of the domestic freight that was moved by roads, and there are over 90% of domestic transport greenhouse gas comes from the highway infrastructure, and there are over 1,600 fatalities happen every year in the UK's highway network. The aging highway assets requires critical maintenance decision-making, but the decision-making process requires good quality of data and functioning information systems. However, in current practice, the highway agencies adopt 2D systems with a very shallow information modeling of highway assets. So all the assets are represented by vectors like lines or nodes. Moreover, there are fragmented asset systems that store different asset classes like pavement, drainage, and structures. And these systems are not talking with each other, which prevents the asset managers to do the cross-asset optimization. To tackle this problem, we investigate the digital twin and the twin systems. A digital twin can be defined as a digital replica of physical assets. So in our context, the physical parts represents the physical highway systems, and the digital parts represents dynamic road information models. And these models mirror the real-world states of the road assets, such as its geometry, behavior, and performance. And the twin system supports the digital models and provides real-time insights, like forecast and decision-making support based on advanced data science models. Although the classical asset management system also provides a digital representation of the highway assets, we differentiate the digital twin concept from the classical AMS by a product model-based approach to manage the road data. And this model would be dynamically updated in its asset life cycle based on the advanced sensing technologies. And we aim to achieve data integration and federation based on the information management framework proposed by the UK National Highway, UK Digital Twin, National Digital Twin Group. Therefore, this research project aims to explore a minimum viable product of a road digital twin, including data modeling and system architecture implementation. We start from literature review and interview with the UK, with over 20 highway experts from the UK National Highways. And we use the information delivery manual approach to document the existing maintenance process and identify the barriers in current practice. And based on these findings, we did a questionnaire survey to a wider range of the people in the highway industry to understand the main barriers, available phase, and the applications and use case of digital twins, and its perceived major benefits. And based on these findings, we would go use this to implement the twin system and validate with use case. So we designed a questionnaire and submitted to over 400 industry professionals in different countries, and we obtained 183 valid responses from the UK, US, India, and China, and Australia. And a majority of the response are maintenance managers, road inspectors, technology R&D, and road surveyors and asset managers. And over 60% of the respondents have over 5 years of working experience. The following question is, what are the main challenges and barriers in your current maintenance process? So we got the result saying that the most selected answer is hard to derive the optimal maintenance decisions under budget constraints. And the following selected options is the inaccuracy, incompleteness, and the unreliability of the asset information. We further group the answers by the types of the respondents. We got the answer saying that maintenance manager care more about the maintenance decision making, and road inspectors care more about the possibility to obtain the comprehensive dynamic road condition data. And on the contrary, we can find that the asset managers care more about the data quality problems. So we can see different kinds of practitioners have different concerns in their professional process. The following question is, does your organization currently use digital technologies or solutions for highway maintenance? We got the answer that GIS is the most used technologies for highway maintenance, and the BIM technology is increasingly used in this area, especially in China. And we also found that there are more and more highway agencies start to adopt the asset management systems and start to do the warehousing, integrating different management systems. In this area, the UK has the highest selection of the AMS. The seventh question is, in which phase of highway maintenance do you see digital twin can take effects? As a result, we found that almost all kinds of respondents selected the scheme making and the prioritization. So that is the very early phase of the highway maintenance. And we further find that the asset managers would care more about the maintenance planning. This tells that the asset manager may be more interested in how they can leverage the rich asset data to get better maintenance results. The eighth question is, what features do you think are important for digital twin system for highway maintenance? And we list several features from the literature review about digital twins, such as prediction of deterioration and structure failures of highway assets, the simulation of maintenance strategies, and the data diagnosis of the real-time road conditions. And as a result, the feature of prediction is the most widely selected option by all kinds of the practitioners. And we found that people who claim that they are very familiar with the DT concept and they have used digital twins also treasure the feature of data storage and integration. The ninth question is, which of the below digital twin-based application do you perceive are important and valuable in highway maintenance? So based on our previous literature review and interviews, we proposed several potential applications that digital twin concept may take effects. And as a result, the application about predicting the deterioration and the structural failures of road assets based on historical and dynamic road data is the most selected option. Asset managers would widely choose the application about helping routine maintenance planners make better maintenance strategy, considering different factors such as budgets and risk and other factors like environment and traffic. And we also find that the scheme makers widely selected generating optimal plans for road investigation and repair. This shows that they generally agree that digital twin may be helpful for their professional workflows. The 10th question is, please describe the potential use case of digital twins in highway maintenance. As a result, we obtained 125 written answers, and we classify these answers into 71 use cases. Since we cannot list all the answers, therefore we present several examples. For example, and maintenance planners written down the answer that a digital twin could be used to visualize the past inspection and the maintenance activities and pin these activities to a specific asset, and then use the data in the digital twin to predict the future maintenance interventions. And the asset managers wrote down the answer saying that DT can be used to understand the interactions between different asset classes and develop the deterioration models that consider multiple assets. And the network manager wrote down the answer saying that DT could be used to simulate the impacts of nature hazards on the road networks. Suppose we have the 3D road models with more detailed modeling of the road defects, so we might create new opportunities to have better simulations. The next question is, please select the potential benefits you perceive of digital twins in highway maintenance. And as a result, most people selected the option of better asset lifecycle management. And this point is strongly agreed by the respondents who claim they have used, they are very familiar with the DT concept. And we also find that people who have used the DT and who are familiar with DT also widely selected the fourth option, which is improved decision making, which shows that they have a higher expectation on the functionality of the digital twin, and they looking forward to using the rich data in the DT to achieve more data-driven applications. The final question is, please select the primary challenges and barriers you foresee in implementing digital twins for highway maintenance. And as a result, skills and training gaps, lack of data integration, and the lack of standardization are perceived as the most critical barriers to implementing the digital twin system in their organizations. And we also find that the people who claim they have used DT and who are very familiar with DT also highly selected the option of resistance to technological change, which shows that they, in their views, DT could be not that hard to implement, but it is very hard to persuade people to adopt the new digital systems. So in conclusion, this research presents a survey with over 180 highway experts to explore the potential values of DT in highway asset maintenance. Our key findings is that this study reviewed the important phase that digital twin could take effects and the important features for the highway DT and the potential applications, 71 written answers of use cases, perceived benefits, and the implementation challenges. Our future work would use these results to do the data modeling for DT, which including foundation data model and a reference data library. We will further implement the twin system and validate it with key use cases. Thanks.